Hello everyone, welcome, and this video is going to be about the basic linear inequality and graphing. So today in this video there are three main different topics that I want to go over with, and the first is how to graph a linear inequality in two variables, and second is how to graph a system of inequalities, and third is how to solve linear programming questions involving system of inequalities. And lastly, I'm going to give you an example. First, for graphing a linear inequality in two variables. The simple definition for this part is that it is a form of inequalities where there are x and y. So the inequality is used to order the pair of the coordinates of x and y where they are substituted into the inequality. The equation you can see on the screen now is the basic inequality. If the equation is y is smaller than 3x plus 6, first, as always, when we put 0 into x, the y-intercept becomes 6. Second, to get the x-intercept, you have to put 0 into y, which makes it as -2. And the other way to do it is that when you find the y-intercept, you can simply use the slope of the equation, which is 3, where you have to go over 1 and go up 3, which can give you the other point. But before you actually do connect them, you should check the inequality sign whether if there is an equal sign with it or not. So if it has an equal sign under it, it means that you have to draw a solid line, since solid line represents that the line is also part of the inequality. And if it doesn't, draw a dashed line, which means that the line itself is not part of that inequality equation. So you should also consider the shading part, where the regions are divided into two, which are first the wanted region and second the unwanted region. And only one of them are shaded when drawn, but mainly the wanted region is the one that is shaded, since it is easier to spot the right points at the end where you can just see the overlapped region. And how you check this part that is wanted is by picking a point and substituting numbers in. So if the inequality is satisfied, it means that the statement is true and that area is the correct wanted region. As you might have already spotted, the graph that is shown on the screen is the graph for the inequality, which is y is smaller than 3x plus 6. Now I would like to move on to explaining how to graph using system of inequalities. The system of inequalities is when there are two or more inequalities. So if we say that the inequalities are y is smaller than 2x plus 4 and y is greater than 3x minus 2, you first have to choose a point of y or x, then substitute that number into the equation and get the correct coordinate. I would like you to use the way I told you in the first unit. You can repeat this 3 times so that you get 3 sets of coordinates before you plot the line, and you can do the same thing for the second equation and have all points ready. Now you can plot the 3 points and draw the graph line. Be careful and check if it is a dashed line or a solid line. And then color the wanted region like it is drawn on the screen, and the overlap region is the wanted region that satisfies both inequalities. Now I would like to move on to the linear programming section. So for all linear programming questions, what you should be pointing out are the variables and the constraints. With the question above, there are a total of 7 constraints. So first, you should point out the variables setting x as a scientific calculator and y as a graphing calculator. The first constraint is that x is greater or equal to 100, and according to the question it says that there needs to be at least 100 scientific calculators each day. And second, that y is greater or equal to 80, and here it also says that there should be at least 80 graphing calculators each day. And third, that x plus y is greater or equal to 200. According to the shipping contract, there should be at least 200 calculators that should be shipped each day. The fourth constraint is that x is smaller or equal to 200, and here it says that because of the production capacity, there should be no more than 200 scientific calculators that are made daily. And fifth is from the same area where that y is smaller or equal to 170, that because of the capacity, no more than 170 graphing calculators can be made daily. And the sixth and seventh constraints are that x is greater or equal to 0, and also y is greater or equal to 0. And this is because all calculators are objects, it cannot be stated as negative. And the last equation we have is that p equals to 5y minus 2x, and this represents the profit. And in order to maximize the profit, we should have the highest value of y, which is the graphing calculator, and the smallest value of x, which is the scientific calculator. So when we graph all these, then we should substitute all of the points to the profit equation, and the number that has the biggest profit is the answer. The last part of today's lesson is to solve another problem of system inequalities. For these set of example equations, first get the y-intercept, which is -8, using the slope of 4, and place 2 more points, connect them with a dashed line as it doesn't have an equal sign. For the second equation, in order for you to get the y-intercept easily, you should first move x to the right column, and from that point put 0 into x to get the value of the y-intercept, which is -1. Like the previous equation, use the slope to plot more points, then draw a solid line through it. Shape the wanted region by substituting numbers in and checking if it is satisfied, and the overlapping part is the final wanted region. Hope you learned something from this video, and thank you!